Hello everyone. Welcome to today's webinar, which is a step-by-step guide to the Department of Energy's ISO 50001 Ready Navigator. As a quick note, we will be recording this webinar and we will have it up on PennTAP's website later today. I also encourage you to use the question and answer pad, also called the Q&A pad, if you have any questions. I won't be able to get to the questions until the end of the webinar, but if you put them in as we go, then you'll help remember and I'll be able to answer at the end. So what will we cover in today's webinar? The first thing we'll do is talk about what ISO 50001 Ready is. Then we'll talk about how ISO 50001 Ready works. It's a navigator tool that's an online web tool, and we'll walk through it step by step. What data needs are needed for each step, and what tools are available within each step. So the first thing we'll touch on is energy management system. So why do we need an energy management system? The big key is that energy is becoming more and more expensive for facilities, and it's one of the main costs that people can control. In addition, many corporations now have sustainability programs all about the greenhouse gas emissions of the sites. The energy is usually the vast majority of where the greenhouse gas emissions come from. So pulling together the energy management system, you're able to reduce cost and improve your sustainability plan. So what are the types of energy management systems? I like to think that every site has some sort of energy management system, but the first approach is kind of a haphazard, ad hoc approach. I think of this as what almost everyone was doing back in the 70s, but people are still doing today, where if you have some sort of light bulb go out or energy using system break, you go out and find whatever's laying around or whatever's fixed, easiest, cheapest, to just grab it, fix it right away, and it's done. There's no real forethought throughout the system. Next is where you'd have multiple people working on energy. And you might have one section of the plant that's going great, energy is controlled, costs are going down, but another section of the plant, it's increasing. Or they're not on the same page. You might have someone purchasing LEDs, but then they get put in the back of the storeroom because no one's communicating to each other properly. Then you have the facility-wide approach, which I think is where most companies are today, in that you have one person in charge of the whole facility when it comes to energy. The trouble is, if you have a great person, they might leave, or you might hire someone thinking they're going to do a great job controlling energy, but they wind up not having the right skill set, or they're doing a great job in one section of the plant, but another site's ignored. Next, we have ISO 50001 Ready, which is the system we'll be talking about the most today. And what that really does is it takes the person from the facility-wide approach and gives them a structure to follow, that everyone has to do the same basic approach to managing energy at the site. And it'll also include procedures and policies that will help make sure when someone transitions out of that role, the new person coming into the role will be able to transition in. And this system is all about self-certification. So there's no third party coming in to review it, which brings me to the next system, which is ISO 50001, which is the international gold standard for energy management systems. But it does require a third party review to get the final certification. And then the by far the best are companies that have done the superior energy performance, which is given out by the Department of Energy. And this includes all of the framework of ISO 50001, but also proven energy reductions with a scale of how much you have to reduce to get bronze, silver, gold, or platinum status. So ISO 50001 Ready is what we'll spend most of today on. And we'll talk about what is it. It's a self-guided approach to an EnMS. And by that I mean it will walk you through step by step what you need to do for an energy management system. It has all of the structure of ISO 50001, but in a simpler condensed version, and it'll help you with templates and calculation tools. So it offers a navigator, which is the step-by-step program we'll talk about today. It also offers an energy performance indicator light tool, which we'll reference today, but we won't go into a deep dive into that tool this afternoon. It's also a self-certification. So you don't need that third party to come in and review all of your information. You really need to convince someone within your top management that you've met all these requirements. And you'll see the very last step is them doing a review to ensure that, but that's how you get completed with this program. So why will you do it? So as I mentioned a little bit earlier, energy helps you save money as well as improve your sustainability score. It'll also give you recognition from the Department of Energy. And for me, the biggest key there is if someone comes in and says to me, Royal, how is this facility maintaining energy, or how well are you doing it? You're able to show them that recognition from DOE to satisfy the answer. There'll probably be more questions coming back later on, but that recognition will go a long way. So this is a brand new program. It just started in 2017. So at this point, everyone's still kind of working through it. But it's a new, great system people can use to get some recognition from the Department of Energy. So it's an online dashboard. And one of the keys I really like to emphasize for this online dashboard part is you are not uploading any specific company information. I'm going to use the example of an energy policy. Step one is going to be, do you have an energy policy? And it's a simple, yes, we have completed an energy policy per these descriptions. You do not have to upload that energy policy to DOE. There's no review of them seeing that information, which is very important because some companies are very concerned about giving Department of Energy basically secret information or sharing this information with them and wondering what will happen to it on the end. None of that occurs with this program. It provides tools, and one of the big tools is the Energy Performance Indicator tool, EnPi Lite, and you'll be able to see how that works through this system. I'm not going to dive into it that much, but you'll see it helps you throughout the process. And it's divided into 4 sections with 25 total tasks. And each task is a part of the ISO 50001 standard, and each task you self-certify to. So this is the General Navigator website. There provides 3 different sections you can go in on. The first section is an about the Navigator, so it gives you the general background. The next, which I'm a big fan of, is an Explore the Navigator. So in here, DOE does not require you to log in to take a look at how the Navigator works. You can pull out all the templates, you can pull out all the tools if you'd like to without ever logging in. But next, there's the login setup, which you're required to log in and self-certify throughout the process to be able to get the recognition at the end of the day. So the Navigator, as I mentioned, is broken down into 4 basic sections. The first section is all your planning work. It's how do you get ready to set up the energy management system. Next is the energy review, which is you as a company figuring out where are we with energy today. Then you'll have the continual improvement piece, which goes into we have all these projects we can do, but how do we make sure we're actually continuously evaluating our projects and continuously evaluating energy? And then finally, there's a system management piece, which gets into how are you ensuring that the continuous improvement is occurring and where are all your documents? So we'll go into each of these tasks one by one to review the system. So we'll start with planning, which is task 1 through 5. The very first task is to figure out the scope and boundary of the facility. So what do we mean by the scope and boundary? It's what will be covered under the EnMS. And the first place I think is the best to start is a facility map. Here we're using Penn State's campus as an example, that there are a plethora of options. You could choose any 5 buildings to include in the EnMS, any 10 buildings, the whole campus. You could start with just 1 building. But it really helps to clarify everything if you keep it on a satellite map of this is the sections of the facility we will be covering. Next, you'll also want to include a process map. So I'm thinking of a map that shows every section of your building with the process equipment including. And that'll help you visualize any distinct separate processes at the site. You might have a complex, diverse facility that on one side is, say, doing countertop repair, and on the other side you have, say, food manufacturing. The process map will help you decide if you want to keep those completely separate or provide them together. Then the final thing you'll need is management input. And really what I'm thinking about here is whether one process line will greatly increase in production or if that process line will shut down in the future. That's the sort of management input you'll need when you're deciding, do we want to include that piece in the energy management system or not? If something's going to shut down within the next year, you might not want to bother taking that into account. And the Department of Energy provides a scope and boundary worksheet that'll help you work through some of these questions and problems as you decide for your facility what is right. Next, you'll be developing an energy policy. And what you'll need with that energy policy is first that scope and boundary. You'll need to know what you're including within the energy policy and what you're excluding. Next, you'll need management buy-in because you're going to be telling the company this is how we're approaching in the future. You'll need just a general list of what the legal requirements are, so you know your policies within the legal requirements and you're not, say, for example, running the boilers more than the air permit allows. You'll need just a general list of the energy sources and a very general plan for reducing energy. So DOE provides the energy policy worksheet, and as you can see there, it's some pretty basic questions that you can pull together, and at the end you'll have a policy written. And I think each question, I'd say, will probably take about 5 to 10 minutes to write a sentence to a paragraph for each of them. Then we're going to talk about management commitment. Management commitment is something you'll need to have documented and be able to prove during an audit. So if you took those first 2 steps, you likely have some level of management commitment already, but you should have some documentation that shows that management is involved in this decision. We will go for ISO 50001 ready, and this is why. So you'll want to set up a meeting with whoever will agree to this in top management. You'll need a presentation and a sales pitch for them to agree. And then you'll want some system to document the outcomes, whether that's a meeting minutes with the agreement in there or an email from the person in top management. You'll want something to back it up when the internal auditor comes in, if you use an outside source, and says, okay, show me your commitment. The Department of Energy provides business drivers and the EnMS resource sheet. It also gives you some background on the Plan, Do, Check, Act components, which are all a part of this system. Next up will be the energy team. So an energy management system is not something one person at the site can do. You need a whole team of people. And when you're starting with that team of people, you'll need to get input from the operations department. You'll need someone from the environmental health and safety department or sustainability. You'll need people from the production side. You'll need finance. You'll need procurement. And you'll need the facilities or engineering team. In some facilities, you'll see that one person covers, say, 3 of these groups. But in other large facilities, you might need multiple people from the production side, or procurement might have multiple layers that you need to work with. So the first person working on this will need a good understanding of both the process, who's working on the process day in and day out, as well as any support areas. And a real huge key is to get passionate people who will want to help you. The last thing you want is someone on the energy team always saying, no, none of us operators will ever change the way we work. You want someone who's passionate and ready to do those changes and help you move through the process. And the Department of Energy helps with an energy team roster. It gives you a bit of an example of who you'd want on the team, as well as an easy layout for how you develop that team. So next, working with your legal department and the EHS department, you'll need to come up with a list of the legal requirements. So first stop should be your legal department, followed by the EHS department. And what you're looking for is what legal requirements do you have related to energy? The easiest one I think of is that your air permit will limit how much your boiler system can run. There's a specific value in there that's either an MMBTUs or an amount of natural gas. That limit you need to have written somewhere and refer to it when you're taking a look at the energy management system. Because what you don't want to do is say, okay, we're going to get rid of these 5 heaters and rely more on the boiler, and all of a sudden you're above that threshold. You'll also be taking that input and looking at the scope and boundaries of your EnMS and making sure that you have everything in place properly. So there's a legal and other requirements tracking matrix provided by the Department of Energy that can help you review this. And there's a compliance evaluation checklist, which, as an example for the legal and other requirements checklist, it has listed out different US EPA permit regulations. So air permit emission limits for boilers is what I was referring to earlier, that if you use too much fuel, you'll exceed those limits and have other legal issues. So that's the planning phase. Next, we're going to move on to an energy review, which is looking at the energy as it currently exists at the site. So we're going to start with data collection. And the very first thing you'll need is all of the utility bills. If you're moving towards an energy management system, you need those utility bills to tell you where you are today, but also in the future to tell you where you're going. Many of you listening will likely have some system set up currently to review your energy bills. Some people, unfortunately, do not have that system. The Department of Energy provides an energy footprint tool that is an Excel file that's organized very nicely to help you keep track of all that energy. So one great thing about this tool is it has a wide variety of fuel sources already built in that will do the conversions for you from, say, gallons of fuel oil to MMBTU. So it's a really great tool that if you don't have a current system to track your energy, it's a nice one to use. It's also something worth investigating that if you have a current system, you can move over to this one probably in a quick, simple manner. Next, you'll actually do an analysis on that data. So the step before was gathering all that data into one spot. Next, we're going to see what's going on with the energy. So the first thing you'll need is, I highly recommend the energy footprint tool. Next, you're going to need a list of all the major equipment at the site. And then you'll need the production data, because once we get to really analyzing the data, we're going to take into account how does production affect the energy usage. So the tools that are available from the Department of Energy are an energy use worksheet, an energy balance example, which walks you through how do you figure out which piece of equipment is using this much energy, and a methodology for conducting an energy balance. So that'll help you in the next couple steps coming up figure out who are the big users of the energy at the site. And in this next step, it's the significant energy uses at the site. So most people think of the SEUs as pieces of equipment. So you'd think of it as your boilers or your dryer, the air compressor at the site. So if we can move along that way, we'll be taking a look at what are those big pieces of equipment. And you'll need to include the data analysis worksheet from before. You'll also want to take into account production data for the future. What is this company forecasting for energy use at each at each year for, say, about 10 years in the future. If you have a piece of equipment that might be running 40% of the time today, it might not be an SEU today, but if you have it running 100% of the time in the future, then you might want to bring it as an SEU today, so you can start working on it and planning for the future. So DOE provides an SEU Future Energy Estimate worksheet, which is what's shown here. And that gets to the point of energy source will change from the current status in, say, percentage used to a new status in the future. There's an SEU control chart and an SEU control chart example. And that helps you figure out what is actually causing the energy use. We'll get into this a little bit later, but is it the people that are causing the usage, the energy usage, or is there a different control system like a thermostat that's using the energy? So the next piece we'll take a look at is all of the relevant variables. What you'll need for relevant variables, starting is that production data I mentioned earlier. You use a lot more energy if you're producing 1 million widgets than if you're producing 500,000 widgets. Then you'll need the meteorological data. And that's really getting at what are the heating degree days for your system and the cooling degree days. As just a very simple example, you're using a lot less energy when operating an oven when it's 90 degrees out than you are operating that oven when it's 30 degrees out. There's that 60 degrees the oven has to make up for. Next, you'll want to look at occupancy data. Some facilities are really driven more by when are people working versus the production. If the production is very steady, you might link up more to how many hours are people working at the site. And then finally, you'll want those management forecasts again. They'll be able to forecast production and occupancy data. Unfortunately, the heating degree days and cooling degree days can't really be forecast in the future, but you can take a look back in time and develop an average for your location. The tools that will help you with this are the EnPI Lite, which I mentioned earlier. That will take all of your current energy data, the kilowatt hours per month, and compare them to the production data. So next you'll need energy and performance indicators. And this is where that EnPI Lite tool will help you. So an EnPI is really just an energy key performance indicator. And what you'll be looking for is a simple way to track energy usage that's normalized. So in the example shown on the right, these are per unit. And by per unit, it means per piece of equipment produced. So a lot of times we call them widgets as just a general piece of equipment, but it might be per pound of tomato cans sent out the facility. Or we've been to some large vehicle manufacturers. It might be per car. This is how much kilowatt hours we want to use per car we've sold. And for the EnPI, at this point, you'll need some statistical knowledge. You're not going to need a master's degree or a PhD in statistics, but you will want to spend some time reviewing from your past what the R² value is, and what exactly does the p-value mean. Because at your site, you might come up with a couple different EnPIs you can take a look at, and you'll want the R² value to help you determine which one to go with. And just want to focus that the EnPI Lite tool will help do all the regression analysis in the background. So you won't need to do any statistical analysis if you use the Department of Energy systems. You'll just have to be able to understand it to be able to explain it to other people at a different time. So once you have all that information uploaded, we'll be figuring out what are the baseline, objectives, and targets for the site. So I think of this as really, what are the goals you want to set? A very common goal is we want to reduce 20% of our energy over 10 years. this step is getting to how long does it take to reduce the energy? How much energy do you want to reduce? And when do you want that starting date to be? So the EnPi Lite tool is great because it'll show you energy going back. As much utility data as you enter in there, you can take account for. And it'll be able to help you see if you've reduced energy by this much over the past 2 years. And in that case, you might want to choose 3 years ago as your baseline. Or conversely, you might see that your energy usage has been relatively flat for the past 3 years, and we'll say, okay, our baseline starts today. This is when we're starting that 10-year clock to reduce by 20%. You'll also greatly need management input at this site at this time. They'll be able to tell you how many resources you'll be able to use over that time. There's a huge difference between being able to do a short-term burst of energy reduction with management commitment and without management commitment. If you don't have the capital dollars and the people's time to do that short burst of energy reductions, it's not going to go well. So next up, you'll take a look at what the improvement opportunities are. Now I'm going to stress at this point, you'll want to go through and do an energy audit. You could have a third party come in and do it, or work with your energy team to develop those improvement opportunities. And this includes both big, large improvement opportunities such as replacing your boilers, but it also includes smaller, simpler reductions. For example, it could be as easy as changing out thermostats to be more accurate, or going around and lowering the thermostat from 70 degrees to 60 degrees. Those all count as improvement opportunities, and you'll want a long list of them so that you can prioritize them. And you'll also want to take a look, how will those affect the EnPis as we move forward? Will we be focusing on making improvements to the SEUs we mentioned earlier, or will we be making improvements to just generally around the facility? There's a prioritizing worksheet available from the Department of Energy that is used in this example that'll help you give kind of a rating scale to the description. Does it save $10,000 per year or less? That only gets rated a 1. Versus if it saves $100,000 a year, that's rated as a 4. So you can use that to help normalize all the different opportunities into one scale. And in that case, you'd likely do the opportunities that wind up having the highest sum on that rating scale. Then once you have that list of opportunities and you've prioritized them, this is the step where you actually go and start doing them. You start saving the money. And as anyone who's worked with a team, there's a couple things you really need when doing these projects. The first thing you need is to assign a person to it. Say, Royal, that's me. I'm going to do this project. Matt, who's one of my coworkers, you should do this other project, and give each of us specific examples, specific projects to work on. But not only will you need that person, you'll also need capital budget. You need some money to get the project done. Regardless of what the project is, there needs to be some sort of money allocated to it to help move it forward. And I guess with the budget, it doesn't necessarily need to be money, it could be time. If someone's going to go around and change all the thermostats, they need that hour or two to fully implement that. And then there needs to be a schedule. So you'll need to have, by December 31st of this year, we want Royal's project to be completed. And the Department of Energy provides an action plan template, which you can see here gives you the action item. So that could be change out the light bulbs in the warehouse, the responsible person being Royal, due date, the end of this month, and the required resources. Say I need $20,000. That'll help keep you organized within your team. So we've done the energy review, and now we're going to move on to continual improvement. So the first step is monitoring. And this is really about monitoring the energy at the site, and this is about how is it done. So step one is, do you need sub-meters on certain sections of the site or certain pieces of equipment? That's sort of a case-by-case evaluation to determine, should we put a sub-meter on this to see how much electricity is going to our process line, or should we develop procedures where people are taking records of how much energy is used continuously? And sub-metering can be a bit tricky because there are meters that will automatically fill in an online program and everyone has access to a dashboard, but there are also meters that someone physically has to go over and review every single day. So you'll need to pull together a monitoring plan and figure out what is currently being monitored, how is it being monitored, and how often are you going to review that it's being monitored. Now, next up is the actual measurement from the monitoring. So you'll be taking those records from, say, the sub-meter. You'll have a list in the procedure that says X number of natural gas was used today, Y number of natural gas was used yesterday. Now, this piece also includes calibration. So the big question is, how often should you calibrate your monitoring equipment? And that's something this section will help you work through. It's got calibration records, it's got an example calibration plan, and you'll have to develop an energy measurement plan. And within there, you'll want to take a look back at the equipment manuals to see how often the manufacturer recommends you complete those calibrations. There's also a key that some of the meters you won't own. For example, the electricity meter coming into your site, the utility probably owns that. And how do you work with them to make sure it's being calibrated properly within your system? So then we have operational controls. And I think of operational controls as really two separate, distinct situations. The first is the operator, the human-controlled systems. So you'll want to go around for all your large pieces of equipment and figure out, how is each operator controlling it? An easy example could be a saw, that if you talk to the operator, one might be really great about sawing everything quickly within one time frame, shutting it off so it's only on for 2 hours per day. You might talk to a different operator that leaves the saw on all day long and cuts pieces of wood throughout the time. I'm also really going to stress at this point that you want to talk to every single operator that uses that equipment, because you may have a situation where the daytime operator is using the equipment exceptionally differently than the nighttime operator. They might have different jobs, they might have different reasons for operating it that way. It purely could be that they've never even talked. They might not realize the person does it a different way, and one might realize, hey, it's better to operate it that way. So you'll need to talk to each of those operators to figure out how the equipment's being run. You'll also need to take a look at any procedures that are occurring. If the operators are supposed to be running it exactly by this procedure, you'll want to compare that procedure to how they're operating today. So that's all step one, as a human actually operating the piece of equipment. Next, you'll have some control systems. Kind of think of them as machines, but an easy example is an occupancy sensor. There's not actually a person going through and touching that light. The occupancy sensor is doing all the controlling of the light. You might also have this within your compressed air system, that the compressors are taking a look for pressure in the system, and they'll turn on and off as it needs it. But those are things you need to be able to understand and figure out, how often do I need to actually consider these occupancy sensors? The occupancy sensors may have been put into the office 10 years ago that no one's paying attention to, and have a set number of them that are no longer working. So you'll want to make sure you have a list of all of those and consider them within your energy management system. So The Department of Energy provides a checklist to help you with this, as well as an operating criteria worksheet that'll help you review all your temperature set points and the differential pressure needed. There might be a liquid level alarm, say you have on a fuel tank, to let you know how low it is. So next up, we'll talk about corrective actions. Corrective actions, I'd say, generally result from an internal audit. You'll be going around taking a look and seeing what procedures are being done properly, who's following the procedures exactly correctly. And that even includes people on the energy team, that you'll want to take a look and say, oh, I'm supposed to be doing this by the end of the month, and I personally have been waiting till the 5th of the month to do it. That's a corrective action. I need to get it done by the end of the month each year. And at this point, you'll also want to take a look at the legal requirements and review how the monitoring is working out. At this point, you'll also have what are called preventative actions. And so not all corrections to the energy management system are due to people doing things wrong. They could be due to an employee having a new idea and suggesting that if we run the oven for 1 less hour per piece of product, the quality doesn't suffer, but we'll save that much energy. And the Department of Energy provides a corrective action and preventative action request log that you can use to track all of that information. So next, we'll be going to energy consideration and design. And I think of this piece as really pushing you towards having energy throughout your whole process. So if a new piece of equipment is going to be brought into the site, it should undergo what's called a life cost analysis, an energy life cost analysis, which will take a look at what does the energy cost throughout the whole system of whole life of the equipment. If the equipment's going to be used for 10 years, how much is the purchase cost? How much will energy cost during that time? How much will any of the consumables cost during that time? And then finally, how much does it cost to dispose of that? And once you factor in all 4 pieces into the equation, you might realize that spending an extra $500 for a piece of equipment will help you in the long run versus going for the least expensive version. So with that, you'll need to provide training for your procurement staff and your engineering staff. If they're not familiar with doing the whole life cycle cost of each project, you'll be presenting them with a change that they'll need to get on board with and help with. And then you'll also want to consider what are the major sources of equipment at the site that you might be replacing in the future. So next we're on the system management piece. And system management is all about, at least to me, documentation and backing up what you've done in those first 3 steps. Which documentation and records is the first task in this system. So in any management system, the first step is actually to do the work. But management systems are really great at making you prove that you did it. So you'll need to have all those records, and you'll need to be reviewing them regularly. So it's one thing to say, oh, yep, our boiler operator's writing down the fuel usage every single day. It's another thing to physically go there once a month, review all of it to double check that he's doing it. And you'll also need that in an organized place. If you have the boiler operator putting it in a binder in his desk drawer that no one else can find, you're going to have a lot more issues than if you set up a spreadsheet that's on the common server that he can add information into. Now that might require a little bit extra work initially to get that spreadsheet set up in the nice organized spot, but it will save you in the long run. And it'll probably actually save him work once he's able to get used to the new system. The Department of Energy provides a document control index and a record control index to help you stay organized where all these records and documents are. So next up is communications. And I like to think of this as how do you get the word out to every single employee about the energy management system. So the first thing first group you'll need to engage is the communications department. It'll help a whole lot if you can work with them and get that group to assist you with, say, graphs and turning a long technical description into a plain word analysis. So you'll want a plain language description of your EnPIs. You'll want the plain language version of all your goals and your objectives. And there's a couple different ways to get the communication out to all employees. And I'm personally a fan of do more than do less. So one way many people do is to have an email sent out to every single person in the company. The trouble is not everyone looks at their email. So then you could go into the break room of each facility, and it might be multiple break rooms in large facilities, and have graphs and that write up from the email put in those break rooms. You can also put the information on your server and have it brought up during meetings regularly that, oh, our EnPIs have reduced 5% since last year, and discuss it in multiple ways. So you really need a whole plan. And that's why the Department of Energy provides the communications planning worksheet, which will help outline exactly what you're going to do to communicate it to all of your employees. Next up, we have training, which is definitely linked to the communication, but this training is much more specific. Whereas the communication was for all employees, this training I like to think of as focused on the operators of the SEUs, as well as other people like the procurement and engineering systems that'll touch the EnMS more directly. So again, you're going to need a communication plan, and it'll be a different communication plan than earlier because you're focusing on a smaller subset of people. You'll need targeted presentations. And when I say that, I mean along the lines of you will be making a presentation that goes to your engineering staff. And with your engineering staff, you'll be able to be significantly more technical than when you do a presentation to, say, an oven operator. The oven operator will only want to know about the oven specifically and how they should operate it with its effect on the EnMS. The engineering staff will be talking about sort of a more broad approach, that if they have ideas that reduce energy, how should we work it into this management system? You'll also need employees' time, and you'll need a good chunk of it for each person. You might be able to have, say, half an hour with the operator to be able to improve to explain the procedure and the new record keeping. But for the procurement staff, you might need up to a half a day depending on how much you're changing their existing job. And the Department of Energy provides a training needs planning matrix that will help you kind of focus in on who do we need to train and what do they need to be trained with. So next up is the procurement, which you'll want, very first thing you'll want is what are the common purchases at the site. Say, for example, how many light bulbs are we buying per year? How many filters for our HVAC system are we buying? So you'll want to take a look at that. You'll want to make EnPIs specifically for procurement. And those can help you significantly in the long run. I'm thinking for, say, light bulbs. If you give them how many light bulbs they should be changing out, say from a T5 to a new LED each year, that'll help you focus on how much energy is saving, but it'll also help them reach a goal. You need the life cycle cost training we mentioned earlier. So this section is really spending time with your procurement staff to figure out how they do their work and how you can fit the EnMS into their work. And the Department of Energy will provide you the life cycle cost assessment worksheet, which I think is a great training tool when talking to the procurement staff to help them understand everything you're considering in there. So then we'll have internal audits. And internal audits is a bit of a tricky name because you can actually hire third-party companies to come in and do the internal audit. But what you'll need is internal auditor training if you're going to do it yourself, or to hire an outside contractor. And really what you're doing at this site at this point is taking a review of every single thing within those procedures, all the records, all the talking to all the operators to figure out what are the strengths of your management system now and what are the weaknesses. And regardless of how well you implement the EnMS, you're going to come up with some sort of weakness. You're going to have a miscommunication with an operator. You're going to find the records were being put in the wrong spot and purely by accident. But you'll find a couple of those and you'll be able to correct them and move forward. So the internal audit, I think of as finding those challenges, correcting them, and then you're on a great path. And these internal audits have no specific timeline continuing forward, but annually is a good time to do it. You'll also need internal audits for recertification under ISO 50001 Ready, which I'll explain in a few minutes. So the second to last step is to calculate your energy savings. And you'll go back to the utility bill data you had, all those relevant variables, the new energy usage over the time, and put that into the EnPI Lite tool, and it'll give you savings. So in this example, they did a great job. The site saved almost 19% of the energy over this timeline. So you'll be adding all of this into EnPI Lite, and EnPI Lite will give you that savings percentage for your EnPI. And again, as I mentioned earlier, it's doing regression and a regression analysis in the background. So that's personally what I really like about the EnPI Lite tool, is it does all the complex math without me needing to do it. I still need to understand it, because if I'm going to the vice president of the company to explain how this 19% savings occurred, I'll still need to be able to explain that yes, it's based on a statistical approach, but I don't have to sit down with an Excel file and mess around with it. So finally, the very, very last step of the ISO 50001 Ready Navigator tool is a management review. So we're bringing in the top management we talked to in, I think it was step number 3, showing them the EnMS, showing them what we've achieved at this point. We'll have to give them a presentation. We'll have the whole energy team there, and each person on the energy team should get a chance to show off the projects and the great work they did, and really show management that all the requirements have been met. And that's very important, because the last step to getting your recognition for this project is to have management sign off and do a self-attestation that you've met all the requirements. So the certification is right down here. It's a pretty simple one that doesn't push the company to do too much, but there's a 1-year renewal process. So once you've gone through the Navigator, the Ready Navigator tool, you've had your management sign off, you are recognized for 1 year. You get an additional year with a renewal process, a nice, simple, easy renewal process. But after you've renewed twice, you have to complete the Navigator process again. But completing the Navigator process the second time should be significantly easier than the first time, because it'll be, instead of creating an energy policy, you'll be updating your energy policy. And instead of creating procedures, you'll be updating your procedures. And when management comes in, they might still have 50 questions, but it'll be an easier 50 questions because they've already gotten the background of the energy management system. So support while completing the Navigator tool is something people ask for often. The first thing is, as I mentioned at the very beginning of this webinar, this will be recorded and put on PennTAP's website. So if you've found it helpful and you want to jog your memory while filling out the Navigator tool, feel free to go there and take a look at it. Also within the Navigator, the Department of Energy has provided tutorials at each step. So you can watch the video right as you're filling out the information. So next I'm going to talk a little bit about PennTAP and about what our services are. So our first set of services are energy management services. So we'll help you with the energy review. We can do a gap analysis, which is determining how close your system is to the ISO 50001 requirements. We can help with implementation. We can help with the training. As I mentioned, there's a lot of training that can occur within this system. And then finally, we can help with the internal auditing. So our energy review is basically that we'll come into your site and try to figure out where all of your energy is going. We'll take all the utility bills and plug them into a nice, easy calculator system. We'll walk through your facility and use some equipment to figure out what percentage of the energy is going to each piece of equipment. So if you have an oven, we'll work to figure out, is it getting 50% of the natural gas or merely 10% of the natural gas? And in the end, you'll have pretty much a pie chart of where all the energy is going with some backup information. We'll also work on the EnPls at this step to help you figure out where you should be focusing your time. Next up, we have a gap assessment, which is us coming in for about a 2-day period and working with you on what are the strengths and weaknesses of your current system. And anyone who's been through ISO 14001 will see it's very similar to an internal audit. But it's a little bit different in that these are things you won't necessarily have had needed in place. So we'll identify that you need a procedure surrounding energy. Or we'll say, if you have ISO 14001, we'll say you need to update this procedure to include energy within it. Next, we have implementation support, which this is when we'll come in, usually after the gap assessment, and help you work on those procedures. And we'll help you work on training each of the operators and talking to them to figure out what's needed and what's not. We can also help with the organization of the work. A great example is we can help work on that energy policy. If you're stuck at just that early phase, we can come in, help get it in motion, and help talk to upper management about why this is required. Then we have training, which this training is mostly around internal auditor training and explaining what an EnMS is. So we can come in and talk to your energy team. If you have the energy team established, but they don't know exactly what they want to do with EnMS, we'll help walk them through the whole EnMS process to give them that background, as well as answer any questions they have. Then we have auditing support, and this is where we come in and we can do the internal audit for you. It's usually a much better approach to not have the people on the energy team doing the internal audit because they're invested within the system. If you're a bigger corporation, it's great to be able to have someone from a different facility come in and do this internal audit. But PennTAP can come through and do the internal audit as well, and we'll work with you to help correct those issues. So it's just a very brief success story. PennTAP helped Volvo, which was the first ISO 50001 facility in the United States. Over a 3-year period, they saw a 25% increase in energy performance. They saved $377,000, or they spent $377,000 to implement SEP, but then they saved $866,000 per year. So they did a big investment to get their energy management system implemented, but they saved significantly more per year actually having it in place. So it was merely a 5-month payback. That's an incredibly quick turnaround to make your money back. Next, we have MedImmune, which is a different company PennTAP assisted. So they were certified in October of 2014. They were the first biotech facility to be SAP certified. They have over $1 million per year in annual energy savings, which is a fantastic number. And they had a 8.5% increase in energy performance over 3 years. So next up, I'm going to talk about PennTAP's other services. So that first group was energy management services. The next we'll be talking about our grant-funded services. So we provide pollution prevention and energy efficiency assessments at manufacturers throughout Pennsylvania. We also do larger projects that bring in lean manufacturing experts to work with us. So the lean manufacturing expert will take a look at process lines to improve it from a lean manufacturing standpoint, and PennTAP will be partnered with them and take a look at the energy and pollution prevention opportunities. This is generally for larger companies that we work with that have multiple process lines we can focus on. Then we have a building retuning program, which is a workshop and site walkthroughs for schools and municipal governments that we take a look at the low cost, no cost, simple ways to have them save money. Next, we have our innovation team, which I'll really focus on the Learning Factory, which is a group of Penn State students, they're seniors in engineering, that for a small fee, you can get 5 or 6 engineers for a semester. You give them a project and they work forward on that project. And it can be things like designing a new walking system. So it's actually a crutch that I'm picturing. So a crutch that might be hard on the shoulders and elbows. There's been Learning Factory projects to replace that with a whole new crutch system that improves the walking ability of people who have broken legs. And then there's also to a different project, which we have one Learning Factory group working on a client that's building their greenhouse gas carbon footprint at the moment and working towards a sustainability report for that company. So you can have a wide range of projects occurring. In 2017, PennTAP had 147 cases with $5.1 million in economic benefit, and we engaged 442 students. So now we're at the question and answer portion of the site. So far, no one seems to have added any questions to the Q&A pad, but feel free to ask any questions. And if there's any section that I went through too quickly or you would like more detail on, please let me know. One challenge is that there's a lot of information to cover in just an hour time period. So I'm more than happy to go back to any of those 25 steps you'd like to have me review again. So I'll give it about 5 minutes for anyone to add any questions, and then after that we'll close. And thank you everyone for joining me through this talk. I really appreciate people taking their lunch hour to learn about energy management systems. So we haven't gotten any questions yet, but if you think of any later on, my contact information is shown on the screen. You can email PennTAP at psu.edu, or you could take a look at our website, which is www.penntap.psu.edu, and you could go there for more information. So with that, I'm going to close down the Zoom meeting. Thank you all again for attending, and feel free to reach out to me if you have any questions at any point. And this webinar will be uploaded to our website within the next day. So if you want to take a look at it again or know anyone that would like to, we'll have it up there ready to go. Thank you so much. Bye.